So basically, this lab is a continuation of the first lab under the assumption of line charge situation. We assume the charge is now distributed evenly across the tape. Then we create a model to show the interaction between two tapes. The results I got from the lab are the magnitude of the charge for each of the tape is 1.758 to the negative 8 coulomb. The electric force Fe is 1.39 to the negative 3 Newton. These are the physics involved in this lab. Newton's second and third law, the electric force and field formulas, and we also know that like charges repel and unlike charges attract. Data, measurements, and observation. The first observation I made is that the two tapes still repel each other like in lab 1. The length I measured is 0.142 meter. The mass I calculated from the conversion formula is 1.42 to the negative 4 kilogram. The distance, the horizontal floating distance, is 0.038 meter. The charge magnitude is 1.758 to the negative 8 coulomb. The gravitational force and electric force has the same magnitude of 1.39 to the negative 3 Newton. Here's my glow script code. The first part of the code is the electric field function. The second part creates a line of charge. The third part creates two spheres representing the two tapes, and the remaining parts creates the arrow of electric field and force and also the magnitude of them. Here's my glow script result. The red sphere represents the top tape, the blue sphere represents the bottom tape. The white arrow represents the electric force of bottom tape on top tape, pointing up. The yellow arrow represents the gravitational force of top tape, pointing down. The green arrow represents the electric field of bottom tape acting on the top tape. Q&A for Lab 2. The magnitude of the charge on one piece of tape is equal to 1.75814 to the negative 8 coulomb. The assumptions I made is that first, ignore air resistance. Second, we assume the both tapes has about the same amount of charge and is evenly distributed. Continued. When we do the comparison between the situation of single point charge and line charge, we found that the line charge situation has larger value than in the single point charge for the charge magnitude. These estimates differ because they have different accuracy under different assumptions. The line charge is more likely to be closer to the real value. The single point charge is a generalized situation that allows us to do easier calculation, while the line charge represents the real-life physical phenomenon. Thanks for watching and have a great one.